result of someone looking into this add transceiver with a kind attribute instead of a track attribute, and it can be discussed if the direction of that kind of transceiver should really be send receive. The person filing the issue thought it should be receive only. And a second question is, what is the mid for that transceiver? The mid question is resolved, and there is a pending mid at creation which may be overridden by the SDP answer, and we think that was already covered in the specification. For the direction question, what is the default? I mean, if you don't add any specific direction when you create a transceiver, what should it be? And the spec right now says it's always a send receive transceiver that is created. As I said before, it has been argued that the transceiver that is created with the kind attribute instead of a track should have the default direction receive only. But my recommendation would be to keep send receive. It is simple to have it in the same way all the time. I haven't seen a very strong reason for changing it. And if you want something else, you can easily do it when you create a transceiver. Is there anyone that thinks we should do something else here?
This is Janivar. Just a backstory there. There are basically two use cases, right, for this. One is to create offer to receive only, to implement that as a receive only track. You're just going to receive audio, not send it. And the other one is to negotiate a track that you want on track to fire remotely so that you can use replace track later. And those are, it's a little confusing maybe that we have a single method to do those two things. So I think that's where the question came from. I also think I'm happy to leave it alone.
So you can certainly set the direction after doing add transceiver, so that you can get to the second case.
Yeah, you can do it, and you can do it when you create a transceiver as well.
Here,
with options.
Would this break a bunch of stuff if we changed it at this point, like break a bunch of running code for no particularly good reason, or?
Karen, you're very faint.
Yeah, I could barely hear you.
Okay, sorry. I was going to say, would this break existing running code if we changed it at this point? I suspect it would.
I think the Firefox implementation is consistent with the spec right now.
Yes, it's in Firefox nightly, and we're coming up on going to beta soon. So it's not too late to change, but it's getting late.
So.
Yep, I hear no one saying we should change this, so let's keep it. Then there was a follow-up question. I mean, should you be able to do replace track even if no track was ever attached? I mean, if you create a transceiver with kind and then do replace track, and the conclusion is yes, and in fact the warm-up example in the specification does exactly that. And then there are some further insights. We need to clarify send a bit, because the text now about replace track says that you're replacing the new track instead of the track currently being sent. And in some cases, I mean, maybe you don't have a track, or maybe the transceiver is inactive, so you're not in fact sending anything. And then also Taylor brought up that we need to clarify that the direction should not be considered when you determine if negotiation is needed when you do replace track, because you might want to replace the track even though you're not currently sending. So when you start sending again, the new track will be sent.
Janivar again, I could speak to that sentence. The replace track language around whether negotiation is needed it needs to be rewritten. When it was written, it only considers the simple use case of replacing something that's already sending, and it can be it's not clear what should happen. Well, it should be written to not. The goal was always to make sure that you wouldn't leave the system in a failed state where you try to replace something that couldn't be sent because it had the wrong encoders. It was never the intent, I think, to have replace track only say work in a stable state. It was never the intent to have replace track fail unless you'd already negotiated connection, for instance. So I think we could solve that unless someone disagrees with that statement.
Can you take on to create a pull request to update that?
Yes, I can do that.
So Bernard, do you catch that? Okay, let's move on. So it's your turn now, Jan-Ivar.
All right, so this was some feedback from someone on our DOM team. Apparently the best practice in WebIDL is to prefer, so this is about a dictionary member in return from RTP synchronization source. It's the voice activity flag. For background, Firefox implements the method now gets synchronization source. We do not implement yet the voice activity flag because that's quite a lot of work. The device is right now the dictionary member is both required and has a nullable, and we got feedback that's saying that you shouldn't do that unless you have well, basically that's a combination you should avoid because it leaves inconsistencies in the web platform. If something is missing, it should use optional, not required and nullable. It's a sort of a faux optional, if you will. So to fix that, we propose that, well, I would like to allow implementations to not implement voice activity flag like Firefox is currently doing, because that's a considerable piece of code. So we'd recommend removing the required flag on voice activity flag. So that would mean that if the member is missing, it's unimplemented. If it's present but contains null, then that means the packets have no header extensions marking, telling you anything about the voice activity flag. And if it's false or true, then that's the value of the voice activity flag that is present. So that's the first question, if anyone has any problems with that. But the second one is where implementation is required.
Question on the first one first.
Yeah.
I think when we wrote this, we thought it was trivial to implement. Could you explain why it's complicated to implement?
I think there was some question of whether this should be generated by the browser if the packet was not present. I could be confused.
Okay. I mean, we have a lot of sort of switched conferencing stuff that is relying on this being implemented one way or another, and it seems like it should be completely trivial. So
okay.
I think we should dig into it, why it might be complicated, because it might be we're talking about the wrong thing. I know people have occasionally been confused and thought this meant they had to implement an algorithm to figure out what was background noise and what was voice. You don't need to do that. That's not needed.
Okay. So it may be that it might still be too late for us to put that in Firefox beta, which is coming up in a week. So, well, in that case, to go to the second point, just to set the precedent here, or to describe the thinking of how to describe the WebIDL in these kinds of cases. So where implementation is required, like for the audio level, which we have implemented, the idea would be we would use optional and not null. And so we would remove nullable and have it be optional. So there means if the member is absent, it means there's either unimplemented or no header extension. But basically, you should implement this. So there's no way in the API to tell whether a browser has implemented it. And tell that apart from there not being a header extension. And so the presence of the member means there's a value. And then we'll try to fix Firefox as soon as possible.
Well, if there is no header extension in the header extension dictionary, then I guess that tells you there's no header extension.
Right. So the difference here is whether the API should let JavaScript do feature detection or whether the presence of the get synchronization sources method alone guarantees that these are all implemented. And I should clarify, audio level is implemented in Firefox. It's just there was a question raised about voice activity flag, whether to change that to also follow the optional with no nullable, in which case we have a bug. But in any case, that seems to be, does anyone disagree that that should be how we treat these combinations of when we use optional and when we use nullable? And then we should avoid having required and nullable.
No, I agree with that.
I mean, I don't have any disagreement one way or another, and I don't understand, but I think we should be consistent across the spec, and I do wonder about if we're breaking things. I'm happy with whatever people decide on this one, right? It gives me the same functionality either way.
Well, the first version of Firefox with this feature will probably not have voice activity flag at this point, so we hope to fix it soon after. And that's what the question is, whether the spec then should reflect that some implementations might not have it or not, or if we just chalk it up as a bug.
So I don't want to sidetrack us here because we have a lot of stuff to do. But if we could discuss on the list after this what exactly voice activity flag is supposed to, how that's supposed to be implemented in the browser, to Colin's point, and where that comes from the spec.
Sounds good. We can move on.
Okay.
So this is related about timestamps. So there are two places you get timestamps. One is get contributing sources, also get synchronization sources. And separately, there's also timestamps in stats that we have already. There's some questions of issues filed. It's not possible to tell how old some of these data points are. Like the get contributing sources gives you data back as old as 10 seconds, but there's no way to compare it to any clock that JavaScript knows at the moment, because it's not specified. It only says local clock. So the discussion on the issue here, some good points that came up, and that I think Carl mentioned, we might want to define timestamp in reference to the context global monotonic clock. Right now we don't say anything. We also, at the same time, I think he said he prefers to have something like a wall clock for logs, which is already what it looks like in GetStats. So it would be nice to be somewhat, it would be better backwards compatibility there, in that you get back a number that's reasonably similar to what it was before, rather than off a totally different offset. So yeah, we want to be able to compare timestamps from stats and get contributing sources and get synchronization sources. So it sounds like we want a timestamp that's comparable to either, in JavaScript, comparable to either performance timing navigation start plus performance now, or performance time origin plus performance now. And the reason there are two is a little complicated, but the main difference is that the first navigation start it clocks a timestamp on page load. So when you refresh the page, it will pick up any kind of local time changes, like you change your clock, the user changed their clock on the machine, versus time origin, which clocks a timestamp at the start of the browser and is monotonic from then on. So these two can drift a little bit. So the latter, time origin, is relatively new and was added, I believe, so that timestamps could be compared in workers and across pages. And so the downside of returning something that's the sum of an origin and performance now, of course, is that there's a footgun that was pointed out in the issue that basically don't compare this to date.now. It'll be very tempting because they'll look the same, but they could drift. And that's true for either of these. So I think currently we're leaning toward time origin, unless there's someone who has concern with that.
So performance.time origin plus performance now will give us something that's well defined in terms of the performance interface, and it will give us a number that it's convenient for logging like it was a timestamp, right?
Yes.
Good.
Yeah,
Should we use the same thing for stats?
Yes.
Yes. Okay.
Sorry to say this, but is there an issue with time origin and either fingerprinting or precision? I see we're blurring some of the performance precision numbers for good security reasons. Is that going to affect this?
Well, since we're using performance now, any security measures we do by reducing the accuracy of that would apply to us as well.
I would say that the resolution that anyone cares about for RTP level stuff is way coarser than this sort of the level of fuzzing that's being provided on performance.now, even for the security issues. You know, that fuzzing is in the sub-millisecond range.
Okay, cool.
I guess there's a question here of whether, but if this has high resolution than we need. Is that?
I don't think it matters.
Okay.
Possibly, but I mean, this performance timing is well established now.
It's fairly standard practice to give clock numbers in picoseconds from a millisecond clock tick. So yes, not a new problem.
Okay.
Adam, are you muted?
Looking for the mute button. Okay. So this is an issue that we adopted from the media capture main spec. And I think it was Johan who originally brought this up when he was implementing for Safari. So it's really about sending what the frame rate of the blackness could be. And he discovered that Chrome and Firefox had taken different approaches on this. And I was looking through the TPAC minutes, and according to the minutes, we decided that we should advise, in the spec, we should advise that 1 FPS of blackness should be sent. But when I was looking into doing a PR just for with that approach, and then I found one piece of text in the spec right now where we say that if a track is ended or muted, it should say silence or a black frame in the video case. So there in the spec we actually have text that says that we should only send one. At least that's how I interpret it. But since we came to the conclusion at TPAC that we should keep the track kind of sending frames periodically, I think this text that I've pasted here currently in the spec, we need to update that one. Or another question is, do we, in the case, should we have a different scenario when a track is ended or when it's muted or disabled? Like should we send only one frame when it's ended, or should we send one frame a second when it's muted or disabled, or should that be the same?
So,
question to you for the group.
I had 2 points on that, though. One is that I think we discussed at TPAC the idea of sending one frame, and the objection was, what if you miss that frame, or if you lose that frame? And the second thing is some background here, just to clarify, that muted means different things now, locally and remotely. So if you mute a track locally, and it's actually not muted remotely, so it's still active. However, if you replace track null, that actually stops sending, which is considered muted remotely. So it's a bit confusing, just to keep that in mind.
Yeah, I mean that's what's said. I mean where I took this the last sentence. I mean that's what you said is pretty much the next sentence in that text.
My opinion is that certainly on ended we should not continue to be sending video. So a single black frame would be fine at that point, or even not. One frame per, the advantage of 1 frame per second in a case where you've disabled or whatever, or muted, depending on your definition of mute. The advantage there would be in a conference situation where someone joins, is that they would get a black frame from you as opposed to not getting anything.
Here's the problem with that, though, and what I just said is that when a track is either muted locally or even ends, that only really pauses a remote track because it's a mute, because you can still use replace track to add a different track, and which remotely would look like things are picking back up again.
Mm-hmm.
So it's still being kept alive in a way. So that would be the argument to sending a frame per second, I guess. Or something.
So in that case, what I'm hearing is that we should send 1 frame per second in all cases. Like it doesn't matter if the local track is ended, muted, or disabled.
Mm. So local track is ended, send black. Mm. I mean, I'm not certain I like that idea, but I'm not certain I have a strong objection either.
It's going a bit against what originally happened in that case, but I think that's what Jan-Ivar is describing is kind of what we have ended up with.
I guess, are there any concerns of the lack of traffic causing anything mute to fire or
consent and so forth should keep the NAT binding open?
Yeah.
It keeps the NAT binding open, but if you're talking to you're now translated into a traditional MQTT that's trying to track when participants have just fallen off the world, they will detect it as a disconnect if you don't continue sending video, right? At least at some periodic level. So I mean, I'm not arguing strongly that this really matters. I mean, maybe those will just break those people. But I mean, we've for a long time said you should keep sending video. And remember, a black frame takes absolutely no bandwidth. They're so small, they're amazing.
Yeah.
So and then 1 a second is nothing.
Yeah, exactly. So I think
it's more just the complex, like a delta small complexity of code to have extra cases for, oh wait, I haven't seen anything from the source for a while, I need to send a black frame, blah blah blah. So like I said, I don't have a strong objection to it.
Okay, so then we do for all the local cases of a track, we send 1 black frame per second. I need to update my PR for that.
Good.
So when you say local, you mean peer connections interpretation of this, or do you mean something that's observable by a media recorder?
A local track in the context of the intent of peer.
And what level of strength is this? Is this a should, must?
I said, looking at the
advice.
Notes, we said advice, so I made it into a should.
Okay. I think that's better than a must.
Yeah. Note that we have 15 minutes to end of issues. Just a reminder.
Yeah.
Yep.
But there will be a PR that will be out for review for a while. So.
Great.
Thank you.
Yes, Jan-Ivar, your turn again.
So this is the issue was raised. There are really 2 issues. Is that browsers, for instance, Chrome and Firefox implement. Well, the first issue is that the constraints API, doesn't have any defaults built into it. It's sort of designed to, on purpose, leave defaults to implementation by externalizing requirements to the requesters. So that leads to some incompatibility issues where between browsers that support downscaling and browsers that don't, or browsers that support downscaling but tried to adhere more to allow discovery of camera driver modes, if you will, and there's some questions of when do you downscale and when do you not. So so next slide. Last TPAC, then Peter Thatcher brought up a new constraint, which I think is a good solution to this, because the constraint model is basically, if you care about something, you need to constrain it. Otherwise, you're leaving it up to the user agent. And so I have a PR here that adds Peter's resize mode constraint, modulo box and scale. The reason I didn't add box and scale was I tried to, and it concerned me a little bit. One is that it adds pixels, which I think we previously said we should not do. But it's also incompatible with the constraints algorithm in that the constraints algorithm considers this pool of settings dictionaries, and you have this algorithm to find the fitness distance. So if we had all these box and scale modes in there, which are letterboxed, or these would then compete in the algorithm with crop and scale modes as well as non-modes. And that would be quite unpredictable and undesirable, I think, in that you might get letterboxing just regularly searching for, if you don't use the resize mode constraint at all and you use like width and height, you might get some letterbox modes if you're not careful, because there's nothing in the algorithm. The way the algorithm is written, there's no room for this level of detail in filtering, if that makes sense. So, and so what I added is the resize modes has an enum, much like facing mode is what I based this on. Describes the means by which the resolution can be derived. And I added some, I added none, which is this resolution is offered by the camera, its driver, or the OS. And then crop and scale, which is this resolution is downscaled and or cropped from a higher camera resolution by the user agent. I also added a fingerprinting may that user agents may disguise concurrent use of the camera, meaning other tabs that have the camera open, by basically lying and cropping and downscaling to mimic native resolutions in some instances to obscure that. Otherwise, you can detect quite well the other pages, other browsers that might use. And you can detect its settings, like if Facebook used a certain set of resolutions more, you could detect that. So this is language to leave options for browsers to implement more privacy if they want to. And but it's significant that this should only be done when there is concurrent use of browsing context, so that there's some guarantee that none will work to return non-downscaled, non-processed modes. And
I don't understand what you were saying about the competing. Like let's say we had some other modes here. I don't even really care too much what they are. I mean, wouldn't they just all have fitness distances that were effectively infinity apart, so that they wouldn't, if you set one of them, it wouldn't really compete? Or I guess I'm not following the argument there.
Well, it's that if you do specify constraints, then everything's fine. If you don't specify the resize mode constraint, then basically a mode that is 800 by 600 natively will have the same fitness distance as a 1024/768 mode that had been cropped down or downscaled down to 800 by 600. And even one that was okay.
But it seems like we might want to attack that some other way a little bit by defining a fitness distance for or basically the most pixels, which will always, the most pixel. If we defined a preference towards most pixels, which I thought we did at one point in time, then it seems like it would solve that. You'd always take a non-cropped, non-messed up.
Right. And the other reason I didn't add it is that would be sort of a new feature, and that currently no one's implemented something like this, but Chrome has implemented crop and scale, as far as I know. And it's not clear to me that that's the right level to introduce that kind of formatting, because crop and scale could arguably considered virtual cameras, versus I've never seen a camera output that comes with letterboxing built in. So, and I would also argue that this is enough to solve the problem that we had. And so maybe we should push box and scale to a separate issue if someone wants to argue for it.
Okay. So, and this definitely solves the problem of we can force it to definitely crop and scale to get this particular aspect ratio we need.
Yes.
Or it won't ever maybe not to do that. It will definitely do that, right? Like the one thing that's critical to the users is that they can get exactly deterministic behavior when they need it.
Yes. So if you use the constraints, you get deterministic behavior.
Okay.
And if you don't, you leave it up to the UA. So the last thing I changed was there's a sentence that says the UA should use one with the smallest fitness distance as calculated in step 3, which was a concern from the original issue about what the default should be. And then I added, but may prefer ones with resize mode set to none over crop and scale as a way to allow browsers like Firefox to have a different default. I mean, the should isn't really that strong anyway, but it goes to, there was a question, what was the intent of the working group that the default behavior should be here? Or,
well, I'm sure that the intent was not that the default behavior should be different on different browsers.
Well,
that I'm sure of.
Well, that's odd that you say that, because why would you come up with a constraints algorithm that externalizes all the requests, which basically says the UA can do whatever it wants within the constraints that have been given? And so there's inherently no default in that design. Is the problem. So yeah, for background, what we're thinking of doing in Firefox for downscaling, which is a feature that's coming up for us, is to I don't know, I want to go into too much detail here, but basically any presence of ideal, if you use min, max, and ideal, you're using you're specifying a range and you're saying I want something within this range. But without ideal, you have no way of saying I prefer the higher end of this range or the lower end of this range, for instance. So as a search function, it's useful to not have the default be, well, now that we have crop and scale, I guess you can specify it with constraints. So there's some more leeway of what the default should be.
So,
but the reigning problem here is that if there is a browser that does not support downscaling, it's going to behave very differently from any of the browsers that do. And the constraints algorithm seem to be designed to let JavaScript, to prepare JavaScript that could happen. But if we end up having the defaults always be that you always get what you want, effectively no one will be prepared for such a browser if we think that's a problem.
So one little detail, they just also include that we return the resize mode in get settings.
Yeah, so being a constraint would mean you could get the settings to know whether this is a resize mode or not. And the other thing is before you even call get user media, you can call get capabilities to learn if the browser supports downscaling or not, by whether the sequence contains both none and crop and scale, or whether it just contains none. It has to. So the spec also says it has to contain none, I think. I think I added that somewhere. And so our current thinking in Firefox that we're going to experiment with is to only downscale when we're forced to. So if you specified just a plain value, that would not carry. If you just specified a plain value and did not put a resize preference, we would still look for the closest native mode. But if you forced it with max or exact, we would downscale over failing with over constraint error. That's our current thinking. That would take us closer to where Chrome is, but not give up entirely on the discovery aspect of it.
So the WebRTC PC spec had some text about that you downscale until the complete surface is covered, and then you crop either on the sides or top bottom. But we're not at that level of detail here on how you do it.
I think this isn't really so much. This is about offering up camera modes you might expect from some devices that not all devices have, I think. So rather than a full-fledged crop and scale and box type graphics tool. That's also why I think we should keep the names of these things far away from the CSS ones, which have similar meaning but are applied differently. In there, you're talking about how do I fit something in an existing container, and in there you can also scale up, which we don't do here. So, are you asking, do we need to specify more deeply how things are to be cropped and scaled?
Yeah, that's my question basically to the group.
Well, since we didn't say anything at all before, I'm not sure that we need to do it now.
No, my concern is that we said it pretty specifically in the WebRTC PC spec, but removed it there.
Well, I think it matters more there in that a peer connection takes an existing source that you might have some expectations about what it should look like, and then you do modifications to it. Here, we're getting a source, and a browser can manufacture virtual sources to its delight that are either useful or not useful, and hopefully they're all useful.
This probably works, at least for me.
Okay, so the decision is to merge 502, basically.
Yeah.
Or subject to detailed review, of course. I had one question about the term crop and scale, but then I read the CSS spec again and found that no, it's subtly different from the cover spec there.
Yeah, I saw your comment. I read that too, and I'm not sure it's a full fit.
Yeah, no, it's not a perfect fit, and then we might as well have a different name.
Right.
Okay, next.
Can we do this one in 2 minutes, or should we skip it, you think?
I mean, I can certainly try to get it on people's minds. Well, let me describe the issue at least, and I don't know if we'll get to the proposal. So the one issue here is that GetStats gathers a lot of non-trivial amount of live data and is sometimes called at a high frequency. This basically stems from, there seems to be two uses of GetStats, and one is live operational feedback, where you might use this to detect, is the call going well, do we need to do something? And the other one is accounting, and that's sort of mirrored in different implementations, seem to have different viewpoints of how this should be implemented. So Firefox reports snapshots of live objects that exist at that time only. That means if you renegotiate a track away, that will actually disappear in the stats you get back. Versus, I believe Chrome stores everything that ever happened in that connection. So, the concern was that we now have there's recently this Boolean object deleted that moved to the base class of all stats, which means that the stats might be obsolete or be stale records basically of things in order to track what happened, including the last byte that was sent for some track that was removed or a transceiver that was stopped. And this complicates the API for parsing it, I think, and also slows it down. Well, the one concern is that the ball of data can grow over time. But it also puts into question the data you find. It makes it harder. Every time you look at a piece of data, you have to check this Boolean to see, am I looking at the right record? Is this the live track, or is this an earlier version of the same track that was removed and re-added and is now a stale data and won't move? I can tell that from the timestamp. So all this stuff, it becomes harder to naively look at the stats for sure. So the use cases that we're particularly concerned about would be always on meeting rooms, any kind of connection, or security feeds that are on for a long time. This would accumulate more and more stats objects over time, so that every time we call GetStat, you get like a bigger and bigger object that would be not only takes a little more time for an implementation to return, but also for the JavaScript to wade through. So repeated remove track, add track would accumulate transceivers and related stats. Repeated send or replace track, for instance, you're flipping between cameras, front or back on a phone or security cameras on some kind of panel, that accumulates track stats. Even flipping between the same tracks back and forth would accumulate a track stat object every time. And frequent ice restarts could also accumulate old ice candidates. So I have a spec link that in the spec, it says two things but there's always been this line that this basic statistics model is that the browser maintains a set of statistics referenced by a selector that is sent or received by the peer connection, which I guess is how Firefox interpreted its implementation. So next slide, if we have time. One proposal was Nico Grunbaum and I came up with was to omit.
Oops.
I lost Jan-Ivar.
Yeah, something happened to his mic.
Yeah. Okay.
Yeah, so...
Should we move on to the...
Yeah, I think we have to.
Yeah.
We have to...
First GitHub, now Jan-Ivar.
Yeah.
Yeah.
So, Peter,
Hello?
are you there?
Yeah, you're back.
Right.
Yeah. So the only comment I wanted to add was that I had another idea which would get rid of the memory accumulation too, and that I proposed that in the issue.
Right.
I'd like your comment before we commit to either one.
Okay. I guess I'll just like to ask people to take a look at the proposal, and so maybe we can discuss it on the list.
Good.
Thanks.
Yep. So, Peter Thatcher, are you online?
Are you guys? Can you hear me?
Yeah.
Okay. All right. So I got a bunch of slides to go through. Are you going to drive them, Stefan?
Yeah. You tell me when I flip.
Okay. So I'd like to do the breadth of this first. So I'll try and go really fast, and then if there's something, and then come back to the things that we want to talk about in the priority order of like most important thing first. So when you're listening, please like make a note, like I want to come back to a certain topic, and then we can come back to it. So I'm going to try and go really quickly. So starting off with quick, at TPAC, we decided to make an extension spec and then decide if we'd like it. So we did. Those are the links. The general approach, go to the next slide, is that we're adding a quick transport object, which you construct from an ICE transport. We'll get to the ICE transport later. And then you can create an outgoing quick stream with a create stream method. And then you get an incoming quick stream from a .onStream method. Once you have a quick stream, you can read from them and write to them using a read into method and a write method. And then there are some controls for buffering and back pressure, and for finishing, which is a clean end, or reset, which is an abrupt end. And these map pretty closely to concepts in Quick itself, except for the buffering part, which is kind of specific to JavaScript, I guess. And lastly, you can have access to state. So next slide. The states are defined in the doc. I won't go through it in great detail here, except to point out that it's currently a bidirectional one, and so depending on whether you close or the other side closes, there are periods where you can read but not write, or write but not read. And then there's some there's slightly different behavior for whether you close cleanly or with reset, or close cleanly with finish, or close abruptly with reset. There's a nice little diagram in the spec that doesn't fit on one slide because it's kind of big, but you can go look at it. So next slide. There are a number of issues raised on the list, so I'll just go quickly through each one of these. Next slide. One is whether we should use the word quick charter. I think that'll come up in the charter discussion later, but I thought I'd just point it out here. Next slide. There was some question of whether SCTP was sufficient or whether Quick had good reasons. I pointed out a few of them on the list. We can come back to this. This is probably that we might discuss, but it's worth pointing out that it's something that we can discuss once we've gone through the breadth of this. Next slide. Another one that's more pertinent to the actual design in the specification, probably the biggest thing that is a question mark of what the API should look like, is how we relate to what WG streams. So basically, in the spec right now, we allow WebWD streams to be implemented on top of what we have, and what we have is like I pointed out, a read method and a write method, and then some for blocking with asynchronicity, returning a promise. Whereas the WebWD streams have a much more, if you're enthusiastic about them, full, if you're not, complex API for doing stuff. And an option would be to just provide one of those WebWD streams for either reading or writing and following that same API. So I guess this is kind of a matter of taste, in the same sense that whether we wanted to go with promises and peer connection was. And I think it has some of the same kind of question marks around, do we want to embrace this across the web and be a part of this embracement, or do we think it's too complicated and we just want to do the simplest thing? This is probably something that we can talk about, but I wanted to point it out so we can come back to it. Next slide. Another question was whether we have unadorned quick, which is to say that you have raw quick streams and nothing on top of them. I think that that's actually a great benefit, so that it provides the maximum flexibility of JavaScript. But Martin Thompson did point out that Quick has this problem where if you want to do two different protocols on top of Quick that both use lots of Quick streams, or more particular Quick stream IDs, and there's overlap between them, there's no way to segregate the different Quick streams to know some are for one protocol and some are for another. So for example, if we did a data channel protocol, but then another protocol that was like a replacement for RTP, how did the Quick streams overlap? And right now, there's no way to do that in Quick other than to have two different Quick connection IDs. So I really think that if this were solved in a generic fashion, we could integrate it into the API, but it's not solved in a generic fashion. And I have something I could propose in the Quick working group, but it is an open question of how you can do more than one protocol within the same Quick connection. And if it ever got solved.
Peter, the multiplexing proposal only allows one Quick connection.
Yeah, so this is all whether you're using the same 5-tuple, by the way. You could always use more than one 5-tuple. But this is a bit of an issue. Again, we can come back to it in more detail. I'm trying to just cover the breadth for now. Next slide. Another one is the ALP.
Just for everyone's information, Martin is writing in the chat, but his mic isn't working.
Oh, sorry, Martin. There's a lot more nuance or detail to that topic that I didn't cover because I'm trying to go quickly here, but it is something that we can discuss. So another one that Martin brought up was ALPN, which is basically this value that goes in the client hello that says what application protocol are you doing, and the question is who decides what application protocol you're doing on top of Quick. And Martin's proposal was to let the JavaScript decide, and I think that's a good way to go. Next slide. There's a question about unidirectional or bidirectional streams. Basically, when we made the API, there were no unidirectional streams, and now there are within Quick, and I think we can update the API to allow for both unidirectional and bidirectional without major changes, depending on how we go, leaning more towards bidirectional or leaning more towards unidirectional. But it's something that we could do as a follow-up if we decide to do this work in the first place. Next slide. Martin brought up WebRTC. It's something nice that's in Quick. We didn't cover it at all. It's kind of like a more advanced thing. We're trying to get the basics down first. So I think it's something that we should do eventually, but perhaps something to come back to later. Next slide. So that's all about Quick. I would like to go through the ICE stuff before we, again, I would like to go through the breadth before we go into depth about the things that are most important. So same story for ICE. We decided we want to do an extension spec and then decide if we want to proceed. So we have put those in the GitHub links there. Next slide. The basic approach is we're not adding a new object. We have an existing ICE transport, but we're extending it. Mainly with 3 methods: one to construct it, so you don't need a peer connection to make one; another one to gather candidates; and a third one to start which means to do the pairing and the checking and the selecting and everything else an ICE agent does. There's also on-local candidate, which is like a peer connection on ICE candidate, and add remote candidate, which is like the peer connection. The important thing here is that unlike ORTC, we do not have a separate ICE gathering object. There's just one ICE object, the ICE transport, and it does not support parallel forking. So it's kind of like a simplified version of the one that's in ORTC. Next slide. There are some tricky bits around gather versus start. Biggest question being, if you call start but not gather, what happens? We can either be magic and make it gather automatically, or we just require you to call gather. I think that it's better to require you to call gather because it encourages you to do trickle ice rather than the reverse. But that's a question that we can decide which one's better. Next slide. Related to that are ICE restarts. Again, you need to call both because you need to change the local defrag and password, and you need to get a new remote defrag and password. The remote one comes from start. Oops, I have a typo there. It says restart. It should say start. And the local one comes from a call to gather. So you need to call both, just like you need to call both to start the thing in the first place. Next slide. There is a case where you would like to gather more candidates but not change the local UFrag and password, not do a nice restart. For example, adding turn servers like you can with peer connection.set configuration. So we might need a variant of gather that does not take, or you might call it, set gathering policy or something like that. But I think it's more straightforward to call it gather, but have maybe a bool you pass in for local UFrag and password. Next slide. There's the thing about gathering done, which was a whole tricky part of the peer connection. And I think we should just basically do the same thing, even though it's ugly. But that is something that we had to consider in the spec there. Next slide. Then there's a question of stats, whether each object has its own stats. So like an ICE transport has git stats and a quick transport has git stats, or whether there's like one giant stats collector where you pass in all the objects you want stats about. We have to decide which one. So that's something we can get back to. Next slide. Finally, I wanted to point out that Colin had proposed an idea at TPAC about doing more low-level ICE control from JavaScript land, or provide low-level ICE control from the browser, and then JavaScript land can do more of the ICE brains of the operation, more of the ICE agent implementation. So I gave this the name Slice for simple low-level ICE. And I wanted to just briefly point out that it is possible. I think that this is an alternative that we can consider. So real quick, next slide. Basically, Colin's idea is that if you have an ICE agent with all these things below that do like network enumeration and UDP ports, TCP ports, stun, turn, ICE checks, gathering, pairing, timing, etc. Right now, the line between the application and the ICE agent is like the whole ICE agent is in the browser, and the application uses it. Next slide. So Colin's idea is to basically move this line down a notch, where the JavaScript does a lot of the gathering and the pairing and the timing of the checks and so forth, but the low-level components allow you to allocate UDP ports, TCP ports, stun ports, get stun addresses, allocate turn ports, and then do ICE checks. So the idea is, can we expose those pieces within the JavaScript? And I think we can. So I'll try and explain how that would work really quick. Next slide. So here are new objects or new APIs we could add to the browser that would allow JavaScript to do this. There are different objects for different pieces. One for stun, one for turn, one for UDP, one for TCP, one for enumerating networks, and one that I call slice transport. So next slide. This is basically how it would work. There are a number of steps which are basically implementing ICE. The advantage is that the JavaScript can control when and how these things are done, which allows it a lot more flexibility. If you're interested in the details of this, we can go through it, but that's only if you think it's the most important thing to come back to. Next slide. This is how an ICE transport would look, where you can add new network routes or candidate pairs, depending on how you call it, and you can send checks. Next slide. This is how a UDP port would look. You can't use it to send raw UDP packets. Obviously, it's just used for sending checks, but you can control when they're allocated. Next slide. Same thing for TCP, although it's client only. I don't think it makes any sense to have a server TCP port in the browser. Next slide. And then a way to enumerate networks and know when they've been changed and to open the UDP and TCP ports. Next slide. A way to send binding requests to a stun server and get the server reflexive address. Next slide. A way to allocate or send allocation requests to a turn server and then get back a turn allocation, which allows you to get a turn transport, which looks a lot like a packet transport. Next slide. And then this whole thing put together, which I think really is a good idea and is possible to do, would allow a lot of advantages to the app, like being able to do things such as turn first, control over Wi-Fi or cell usage, do continual gathering or make changes without ICE restarts, have long-lived candidates or backup candidate pairs, do variable check rates, do TLS host candidates, which is something people want, and maybe even do parallel forking, which there's no way to do, obviously, right now. Okay, so that's the breadth, ton of things, but now we can pick which things we think are the most important to talk about, whether we want to talk about Quick or ICE or low-level ICE or which parts of Quick. And I kind of want to hear back from other people this is all the stuff that we are doing or could do, and I want to hear back from everybody else about like what are the important things that we think we need to discuss. If I had to pick something, maybe it would be some of the details of Quick around what WG streams and unadorned Quick, and also the whether we think Slice is worth looking into further. But I'll leave it up to everyone else.
So one question about Slice. There have been other efforts to do TCP or UDP interfaces to browsers, and the question is always, what's the security story?
Well, I think here the security story would be you're not allowed to use it to do anything except for plug it into the ICE components that send checks, and then that can be plugged into other components that do DTLS and SCTP or Quick or RTP. So you would always have crypto and congestion control, except in the case of ICE, where you still have throttling, which is part of the ICE spec. So really it just becomes a question of how many ports can you open? Of course, network enumeration would be blocked behind a permission, just like it is now. But the question of how many ports you can create is really what it is. And we can put a limit on there, but that's already an issue with peer connection, where you can tell it to allocate 1 million ICE candidates in the pool. Like, we can put a limit, right? So I think those are the security considerations. Maybe there are more than I haven't thought of.
The security considerations that you're actually concerned about here are the ones related to connecting to hosts that aren't willing to receive connections and all those sorts of things. And ICE sort of mostly deals with all of that.
Well, I don't think that I'm proposing anything here that you can't already do.
Well, exactly my point. Yeah, we already have this idea of consent, and we're not looking to get rid of that.
Exactly.
So I wanted to up-level a little bit. I want to talk about what's most important to do now as opposed to later. I don't have any particular viewpoints on the ICE thing at this point, not having a lot of time to think about it, but the Quick thing is certainly something that I know about, and I'm a little concerned we're getting ahead of ourselves in the sense that there's a lot of things in Quick that are still changing. I hope that things that affect the API aren't changing, but we're not quite at that point yet, I don't think, Quick side. So anything to do here.
But the flip side of that is, because Quick is almost poured into concrete, if there's things we need in it to make it work for real-time media, now would be an awfully good time to be thinking about them.
But I don't think that Peter's proposal here would actually make it viable for real-time media. It simply says, well, what do you have in Quick? How do we use it? And if you wanted to use it for other use cases, then you've got a pretty long road before you actually get to the point where you can use it to the point that you find out about these things. So, for instance, if you wanted to do RTP on Quick, I suspect it's probably not going to work especially well with Quick in its current form. Nor do I expect it to. We'd probably reject those requirements at this point.
Well, I think the discussions we've already had are proof that talking about this early on does help the discussion within the Quick working group. I mean, or at least the discussion around Quick. You know, we've already brought up the demultiplexing thing, and now you've brought up the thing about having multiple protocols over the same Quick connection. So those are things we would not be talking about if we hadn't already opened this discussion. So I think it's good that we're doing it now.
But it's also the case that the Quick working group has explicitly decided not to address use cases outside of its core one. And so while we're quite happy to engage on these things to a degree, we do have a primary focus, which is getting HTTP working. So we have to be careful that we balance those needs and are aware of where Quick's going, at least in the short term.
Right, but we can't even be aware of where Quick is going and how we can interact with them if we're not.
Yeah, I'm not suggesting that we don't work on this. I'm just suggesting that we be aware of the fact that things are changing and they may be changing outside of the control of this group at least. And so you need to be prepared to deal with that. So don't start committing to anything other than, well, commit to things cautiously.
Yeah, certainly. I mean, this spec can never be done until the Quick spec is done, right? Because you can't. It's a hard dependency.
Well, and you also need to remember that Quick is not just one thing. Ultimately, we will come back to use cases like the RTP over Quick, and Quick will change as a result. And so one thing that I didn't put in my review that I forgot was Quick has this notion of version negotiation, and that's something that the API might want to expose because, for instance, there will be different features available in different versions of Quick.
So I think this really highlights that important part of this conversation would be what are the advantages to doing it Quick ICE on all these things, but let me just focus on Quick for a second. What do we get if we did all this stuff with Quick that we can't currently do with data channels or something? And I think as we get crisper on why it is we want to do that, it'll suddenly become clearer about how much we need to drive this now versus later, right?
I agree. I think
part of the problem here is that we have this sort of approach that's taking this, well, let's just provide Quick generically, which doesn't really give you the opportunity to take use cases and apply them to them in that same way. And so there's a disconnect there still.
Right. Well, I wasn't criticizing the approach of doing it generically or anything. I was just saying, even if we're doing it generically, to be able to say crisply, this is why we're going to go do this huge chunk of work, will make it much easier for us to focus this, right?
Yeah, agreed. Yeah.
And why I'm sort of driving that is I suspect for me the answer comes around. If I had to say the one reason that made me interested about this, it has nothing to do with data channels. It has to do with media. And it was that the option of, and I'm going to say media, not RTP, media over Quick, might have a higher firewall NAT traversal rate than what we currently have. That is that's the high order bit for me, right? And it's a might.
That's an interesting viewpoint because there's been a lot of other use cases thrown out, and that's more convincing to me as well.
Right. So, I mean, I guess I'm not saying that everyone else is the same, but getting crisp on what those are for everyone might really help drive this conversation.
Yep.
And I agree strongly. This is the exact point I was trying to make on the list.
All right. Well, I'd like to hear those things. I mean, the one that Colin just pointed out is an interesting one that I had not considered. So it's nice to hear what those are. There was significant interest at TPAC, but it was, people weren't lining up and saying why they were interested.
It's because it says quick. That's the problem. To Fluffy's point about NAT traversal, you may actually find that it's worse than quick with NAT traversal because you're relying on ICE to get you there. Something to think about.
Well, that's our current form, but that's not something that would necessarily be forever.
Well, then you're potentially talking changes to quick in order to get that to work. You can go back to my proposal when the group met in Stockholm many years ago about layering consent into the underlying protocol. And quick does have some consent mechanisms, but they may not be appropriate for peer-to-peer use.
They may be appropriate for client-to-server use, I'm guessing.
Sure, but that's what they're designed for.
Right, but there are use cases where it might be appropriate to have a quick transport without an ICE transport.
That's one of the questions that would need a little bit of investigation regarding the security question.
Yes.
Consent.
Yes.
So we have 2 minutes left on this section. I wonder how we move ahead in the best way. I hear people want to have a discussion on the use cases and so on.
So what I'd like to know is what does the working group want me to do between now and the next time we meet, and what things are the most important to discuss the next time we meet? It sounds like the making it clear what everyone wants from Quick is one of them. And that's all I can do for.
Yeah. And for ICE, getting the security story clear would be a good thing, at least for me.
I'd like to add a point on the security story, which is there's been an interesting discussion about what's effectively drive-by one-way WebRTC connections that are so on the Twitter. I put a link to it in the mailing list as well. But basically, the idea that you could spin up a WebRTC connection without associating it directly with the page and therefore bypass some of the cause mechanisms. So I think we need to that's the kind of thing that we need to see built into that ICE proposal, those getting rid of what are oncoming threats. I think that's the kind of thing I'd love to see in that.
And I agree. Security, taking a look not for the ICE stuff, taking a look at the security aspects and how this will help or hurt that is a very important part, not just what features you get from it.
Okay, so to be clear, on the security thing, first, which part do you want a security look-in analysis of it? The quick part, the ICE part, or the slice part?
Not quick. I wasn't talking about quick.
You mean the ICE transport?
So I'm thinking about the way that ICE. This is currently. You're right that you're not changing what we're currently doing, but there's a school of thought which is starting to say that what we're currently doing doesn't tie sufficiently back to origin, that you can necessarily be confident that your injected JavaScript isn't going to screw you up quite badly. And so that's the kind of issue that we're trying to. I think we should be trying to cover off. It's not an issue yet, but it's one that's kind of bubbling up, and I think it would be really good to address it in this kind of proposal.
Is that also what you had in mind, Harold?
Sorry, I lost it. And what were you saying?
So Tim seems to be interested in CSP-like controls over this and interactions with the origin model.
Tim, can you?
Oh yes.
So, Tim, never minding
part of
this,
the charter.
start an email on the list that explicitly gets out this drive-by problem that you're connecting. So I'm not understanding it. I think it'd be good for someone to explain it out on the list, and then we can all look at it.
Right, sure. I'll take that as an action.
Thank you very much.
Thank you.
Okay, so was there anything else that people want to see changed, or want discussed or want me to do before we discuss things again?
I think the Streams API question is a lot more fundamental than you're giving it credit. We got burned pretty bad on the promises at first callbacks thing. We sort of committed to callbacks because we needed something working and promises weren't ready. But this is not the case here. Streams are ready, they're implemented, and there's general agreement that they're the right way to do these things. And also there's a bug in what you have. It's a minor one, but it's a deadlocking bug. So I think there's no sense in doing anything other than Streams here. Having two APIs is insanity to my mind.
Oh, okay, so this is the question I'd like to know. We're out of time, but I would like some brief feedback on, is this the direction that all WebRTC, or not, sorry, W3C working groups are going, where they're embracing what WG Streams, and like, this is, the new big way, the one true way of doing I/O basically, and so we intend to embrace it?
True for I/O, yes.
Yes.
Less so for other things. And if you look at using Streams for things like media, I think that's probably a little further out.
Yeah, so
I wholeheartedly agree.
So last time I looked at Streams, they were still byte streams, not message streams.
Right. Not to oversimplify, but it basically lets you do JavaScript async for loops. And that's a good API for things like this. It's a bad API for things when you want to have seeking and stuff like that. So, but yeah, I wholeheartedly agree with Martin. We should jump on this and not have two APIs.
And I agree as well.
I mean, if that's the direction everybody wants to go,
yeah. When you want a byte stream, I think streams are fine.
All right. I think I'm out of time.
Yep, I think we need to move on. I think we will need to have a separate call on these topics later on. Okay. Bernard, the charter discussion.
All right. So as people know, we need to recharter the group to continue. Charter is up in, I guess, in the March. So we've gotten a charter proposal up on GitHub. A few of the changes that have been made to the previous charter were the end date, which is extended to the 31st of March, 2020. We added that we're having these teleconferences approximately one a month. There are links to some additional specs. And then we did change the licensing to make it a little bit friendlier to reuse of the specs. Next slide. So we've been having a bunch of issues raised on the list. I guess one which we just chatted about was the nature of the work on Quick. In particular, are we doing some kind of general stream API, just trying to surface an existing API like what working group streams? Is the work just for Quick or just for SCDP? Exactly what the goal is. That's one set of questions. Also, there have been questions about use cases. Do we know what they are? And then a whole bunch of discussion on protocol issues, which mostly is for the ITF, like multiplexing. Currently, there is a limitation of a single quick transport because of the way multiplexing proposal works. Discussions about congestion control, the definition of the quick data channel, ALPN usage. And then part of that was the current charter only refers to the RTC web working group. Should there be links to collaboration with ITF beyond that, like the Quick Working Group or other groups like RMCAT, TSV, WG, or RGs even. So at this point, I think we're trying to encourage people to take it beyond the general discussion into filing of very specific issues on the charter. And then also pull requests so that we can examine the very specific ways to address those issues. I'm not sure if, certainly we have a little bit of time, about 9 minutes, to talk about kind of how to proceed on the charter in general, but it seems like the major discussion is about this new work on Quick and Ice, as far as I could tell. Do people have comments they'd like to make?
I mean, everything I heard in the conversation so far is people are still, we could talk about the details of Quicker Ice, but are very much on the fence of is even really the right time to be doing this in Quick and Ice. So, I mean, maybe we're a little bit ahead of ourselves on the charter here. Maybe we just need, maybe we need to have a meeting dedicated about like what should the working group do next and try and collect that up. So I don't have a real strong proposal, but I'm saying I sure don't see consensus that there is a bunch of people who are willing to go do the amount of work that is going to be required to get any of those things on that slide done. And I'm not saying we won't get it. I'm just saying I don't see us there yet.
I have to have the discussion about whether there was any intent to build the things that we're talking about here.
I have intent to build it.
Oh, you already have
that's great,
it, right?
That's great, but it's not going to be interoperable until someone else does.
No, we're also looking at building it.
It depends on what you mean. Like on the ICE pieces, it's certainly interoperable from a protocol standpoint, just not from a API standpoint.
Oh, sure. ICE I wasn't concerned about. That was the quick one that I was referring to there.
I mean, I think I said this on the list, but my feeling is that we shouldn't be specifically naming Quick as a target. We should be saying the kinds of things we're trying to achieve with it, and that allows us a bit more time, as Colin says, to allow the thing to mature. I mean, if we're saying that that we have the charter in March, then it's a lot of hurry unnecessarily to nail down some specifics about Quick that I think it's too. I don't feel like it's necessary yet, other than that we've got this charter coming towards us, and I think it's a mistake to use that as a forcing function to do it sooner than we need to.
But on the other hand, it would be a mistake to make ourselves a new charter that says we won't do it, because then we're going to turn around and do it before the charter expires.
Yeah, but you're not saying that
right,
you're not going to do it.
Right, it should be creatively vague enough to say that we might do it.
Yeah. Or it could simply omit mention of it, just like the last charter did. That would work fine too. It hasn't stopped people from working on it, and I don't think that the current interaction model is broken in any way. I mean, the feedback that this group has provided to the Quick Working Group has been pretty good, and the engagement has been reasonable, I hope. So I don't think we've got any major structural issues that would be addressed by changing something in the charter.
So I'm hearing we should be a bit vaguer in the new language in the charter, probably.
Well,
investigate and
one way
propose
to be
solutions
vague
to
is
problems.
to talk about investigating a stream API, which wouldn't mention Quick specifically.
No, I'm your guns right. I don't think what we need here is vagueness. Okay, that's not the problem. I don't even care what the charter says. We can do whatever, right? What we need to do is figure out what we're all going to be putting a huge amount of work into, and why. And this is great. I'm supportive of the stuff Peter's doing. I'll be encouraging of this, but when we're still asking what it is that we're trying to accomplish and come up with some thinking about what the dates and timelines for these types of things are, people are going to realize, I want to know who's going to work on it and why, and that it's going to happen, and that there's a bunch of people who really need it, and it's going to do something. I think we should prioritize that and figure that out. And I think when it comes to the Quick thing, an example in specific, what's hurting us is not we don't have a stream API and we could move our current API to that. I mean, we're talking like that wouldn't, we want a stream API. It's not a reason to do quick. And it's not even something I think we really care very deeply about. I don't think we give a crap about that API for the most part. So there's got to be the reason we're discussing this can't be we need a stream API. So let's not write a charter that says we need a stream API.
That will be addressed by SCTP as well. Yeah, Adam, we can hear you.
Sorry, it's not Adam, it's Leonard speaking. Basically, I wanted to say that the Stream API I've mentioned isn't really about the Quick Stream API. It is rather about a streaming API for data channels in general.
That's a separate point, I think, and I was going to make a similar one. If we wanted a streaming API, then we should say that we want a streaming API, and you could certainly retrofit something onto the data channels if that was important.
So as long as I keep hopping on this, but as long as the so-called Stream API is about byte streams, it is an excellent way of handling big messages. It's not at all a replacement for the message-based APIs we have.
Right.
I think it would work differently for data channels. At least with my proposal, I would do one stream per datagram. And then you can have big, large datagrams you can send, but in a streaming way. So that is a different approach than I would propose for the Quick Stream API.
This reminds me very much about the debate on media streams and media tracks and media stream tracks and media. Yeah.
What you just pointed out is the Quick Stream API that we have there.
So we have about 2 minutes left, and I'd like to ask the same question Peter asked. Kind of, how should we move this discussion forward? Should we just do it with issues and PRs?
Issues and PR seems to be the approach that is working.
Yeah.
Well, what I was going to do is start a thread on the mailing list that basically says, please tell us why you want Quick, or what are you looking for? And then I'll say what I'm looking for, but Colin can throw in what he was looking for, and other people can throw in what they were looking for.
Yeah. We have some other frequently requested items. For instance, using pair connections in workers.
Right.
Yeah, that is something I would love to have.
Yeah, me too.
Yeah, many people love it, but we still haven't found. So I think it's a good thing to charter. We need people who are willing and able to spec it and willing and able to implement it. The spec might be easy, the implementation might not be, or the other way around.
So the question is, what do people want, and who is willing to implement it, or who's willing to spec it, and who's willing to implement it? Is that correct?
Yep. Yep. Repeat for each item.
Should there be a topic for discussing potential security concerns? There was a mention that might bubble up.
And it's already bubbled up. Or we have, so Anna in particular is harping at us to that the whole data channel model, especially, is bypassing the CSP security model big time. And the ads and the people who run rings around ad blockers are already using it.
All right.
CSP support for blocking WebRTC from pages that don't want it is, I think, a critical thing to get in.
Does that apply to the current spec with peer connection?
Yep.
Absolutely applies to the current spec.
So it's something that it's a requirement that we totally missed out on specking with it when we did the requirements for this pass, and we need to do it now.
Who's going to do that between now and the next time we meet?
Yeah. Well, and now it's a very flexible concept, or I was using it in terms between the current moment and the future. It will take a while.
No. Do we even know what mechanisms we're talking about using? I mean, people have talked about CSP recently on the issues list, and there's this thing, feature policy, that's coming up, and iframe sandboxing and all sorts of other things. So do we have anything concrete?
I think I understand what feature policy is about, and that goes directly to iframe sandboxing. I don't understand CSP, but others might.
It's all the same. It's all the same stuff.
No. As far as I can tell, it's all mixed up, but it's all different.
Sure. They all address different aspects of the same basic thing, which is, can I use this feature?
Except that CSP also talks about, can I use this data?
Same thing.
Except that you can't enumerate data. You can enumerate features. Yeah.
One way or another, someone from Mozilla will be available to work on this.
Good.
That's really good. Yeah. Okay, I guess we're out of time.
We got somewhere.
Yep. And as Bernard said, please file issues and PRs or write an email about the charter. That's the only way we can progress.
Thank you, everybody.
Thank you.
Okay.
Bye.
Bye.
Bye-bye, folks.
Bye.